Hello, this is Susan Paz. This is section 6.4 on factoring special products. There are 4 special products in this section. The first is perfect square trinomials. Then we'll look in another separate video at the difference of 2 squares. And then in a third video, we'll look at the sum of 2 cubes. And finally, we'll look at the difference of 2 cubes. So I've listed here the characteristics of a perfect square trinomial. The secret to working these is to learn how to recognize them so you know how to start. So if it's a perfect square trinomial, obviously trinomial means it's got 3 terms in it. The other things you need to check for are the lead coefficient and the last term. So my eye is looking at that 81 and then remembering that there is a 1 here on that lead term or the lead coefficient, and both 1 and 81 are perfect squares. You're also looking for an exponent on the lead term that is even, and you see that this lead term is a 2nd degree. And the middle coefficient, and this one is hard for me to write down. If you take the square root of each of those numbers that I've highlighted there in green, if you take those square roots, which would be 1 and 9, you multiply those two together, which would be 1 times 9 is 9, and then double that 9, it would bring you to the 18 in the middle. That's sort of a peripheral observation at this point. I'm just going to be looking right now at the 2 ends of this trinomial. So I'm seeing a trinomial, I'm seeing the 2 ends have an even coefficient and they have a 1 and an 81, which are perfect squares. So the way you factor these is to write down a double parentheses, and then you're going to take this x squared and split it up to an x to the first and an x to the first in each lead positions in each set of parentheses. And then you're going to let your eye travel all the way down to the 81, the positive 81. That's important that it's positive. And you're going to take the square root of that, which of course is 9, put it into both of the second positions in the parentheses. So how do we affix the signs? Well, you go into this middle term. You know the 2 signs have to be alike because the 81 is positive. The highlighted orange on the 18 tells me that these 2 signs must both be positive. Now, if you wanted to do a quick check on that answer, you could do full. So first comes first is x squared. Outer product is positive 9x. Inner product is also positive 9x. And last times last is 81. And so you see these 2 terms here in the middle are like terms, and they will add back up to that 18x. So I'm going to get rid of all that checking. That just kind of confuses things, but that's how you would check it if you wanted to. I lost some parentheses. Let me put those back in there. Okay, so that's one way to write the answer. That is correct. You could also, because these turn out to be exactly the same 2 binomials, you could write it down once, enclose it in parentheses, and then put the exponent 2. So either answer should be acceptable. So let's scroll down to this next one. I'm also noticing a lead coefficient here of 1. My eye is looking at this 1 and this positive 36. Those are both perfect squares. And now I'm checking out that exponent, and it is even. So I'm going to go ahead and try some numbers. So double parentheses, separate the x squared up into x and x. Mentally take the square root of positive 36. Put that in each of the 2 second positions, and then take a look at the middle sign, and since that's a negative on that 12, I'm going to go in and make both of these negative. Remember, they have to be alike because that 36 is a positive. So how will they be alike? They will both be negative. And again, you can write it x minus 6 twice, expanded like that, or you can write it x minus 6 enclosed in parentheses, and then that whole quantity squared. And one more before we stop. I'm looking here at this lead coefficient is 9, which is a perfect square. I'm also looking at this positive 64, which is a perfect square, and I'm checking out the exponent, which is an even number. So double parentheses. So this time I'm working with 9y squared. And what you're actually doing here is taking the square root of that. And you're splitting it up into 3y into each of those first positions inside the parentheses. And then your I jumps down here to the square root of positive 64, which of course is 8. And you put the 8 in each of those 2 second positions, and then you go in here and you take a look at the middle sign. Since it is positive, you know that both of these are going to be positive. And again, you can write it expanded like I have it there originally, or you can compress it into a single parentheses with the quantity squared. So again, quickly before I stop, if you wanted to check this, I would expand it back out, and I would use first times first outside inside and then last times last. So you can see here in the middle how that doubles up in there. That plus 24y and plus 24y will take you back to that positive 48y. This y squared term is different from the others, and this 64 is just a constant. It's actually a 0 degree y, if you remember. 0 degree is equivalent to y to the 0 is equivalent to 1. And so let me again clean up all this checking out here so that you can see that the answer is 3y plus 8 in parentheses quantity squared.